Welcome to this video on Chapter 2, Motion in a Straight Line, a foundational topic in CBSE Class 11 Physics. We will cover 1D rectilinear motion, the use of calculus for instantaneous variables, kinematic equations for constant acceleration, and the concept of relative velocity. To start our study, we must understand the basics of motion. This includes defining a frame of reference, setting up coordinate geometry for one-dimensional systems, and applying the point-object approximation model to simplify complex physical scenarios. It is essential to distinguish between path length and displacement. Path length, or distance, is a scalar quantity representing the total path covered. Displacement, a vector, is the shortest straight-line distance between 2 points and can be positive, negative, or zero. When we measure how fast an object changes its position over a finite time interval, we use the rates of average velocity and average speed. Velocity is defined by total displacement over time, while speed is defined by total path length over time. We apply similar calculus principles to define acceleration. Average acceleration is the change in velocity over a finite interval, while instantaneous acceleration represents the derivative of velocity with respect to time, shown by the slope of a velocity-time tangent. Graphical representations are powerful tools. In position-time graphs, the slope shows velocity. In velocity-time graphs, the slope shows acceleration, and the area under the curve represents displacement. Note that in physical systems, motion functions are continuous and differentiable. Next, we look at motion under freefall, where an object near the Earth's surface accelerates downward due to gravity, neglecting air resistance. When released from rest, its velocity and position over time are governed by these standard kinematic formulas. Galileo's law of odd numbers provides a fascinating insight into freefall. It states that for a body falling from rest, the distances traversed in equal intervals of time stand in the ratio of consecutive odd numbers starting from unity. Finally, we consider relative velocity. Motion is fundamentally relative. The velocity of an object B with respect to object A is the difference of their velocity vectors. If moving in opposite directions, their relative speeds effectively add up. To summarize this video, we covered displacement, velocity, and acceleration variables, the use of limits and derivatives, and kinematic equations. Remember, deceleration is acceleration in the direction opposite to velocity, and board exams often test these calculus-based derivations. This concludes our video review of motion in a straight line. The source of the laboratory equipment image shown in this video is provided here for your reference.